would like to show you now a new artificial intelligence tool that has the potential to assist people with disabilities. This is being developed by students here in the Department of Electrical Engineering and Electronics at the University of Liverpool. First, I'd like us to try and picture a scene. Try to imagine that you have a hearing impediment, and that due to this, your main and preferred way of communicating is via sign language. However, many people, myself included, have little or very limited knowledge of sign language, and this can create a real and significant communication barrier for you to be able to communicate. In certain situations, this barrier could be made much worse due to increased stress or anxiety. So for example, if you've gone for a medical test or an examination, perhaps an x-ray, you might have questions that you want to ask the radiographer taking that scan. But the communication barrier is now increased further because you have the anxiety as well as the issue of not being able to communicate in your preferred language. So how can artificial intelligence help us with that? Well, researchers here at the University of Liverpool have designed and constructed an artificial intelligence enabled sign language glove. Now obviously this is still very much in the prototype stage, in the early testing stages. The circuitry needs to be miniaturized, and the glove obviously needs to be made slightly more aesthetically pleasing than it currently is. However, if you think of the circuitry and the complexity involved in a smartphone or a smartwatch, these are tasks that can obviously be done, and they're not too difficult in themselves. So when wearing the glove, it is possible to make a sign language gesture, for example, hello, and these will then be interpreted and translated into speech. Again, as this is an early prototype, the glove only knows around a dozen words or so.
Hello. Food. Good. Thank you.
Again, it's not a complex task to be able to program it to learn more and more words as time develops. Now, if we go back to our hypothetical x-ray patient, this opens up the possibility of them now being able to communicate in a way they are much more comfortable with and being able to be understood, relieving some of the anxiety and lowering that communication barrier again. But personally, where I think a tool like this really has potential to make impact would actually be on the teaching and learning of sign language. And a tool like this, it can be an incredible addition to lessons and videos, and it enables someone to practice in their own time, in their own space, and get instant real-time feedback on whether the gestures they are making are correct, and if they're not correct, they can see what they need to do to modify them. So how does this glove actually work? Well, like any artificial intelligence-based system, we have three parts. We have some inputs from sensors around it. We then have data processing, which is what's going on inside this blue box here. They interpret the sensors based on a number of preset rules and parameters, and then they give an output, which was the audio speak you heard just now. So in this case, the input comes from a range of sensors that are built into the glove. So you can see these little strips that are based on all the fingers around the glove here. These are what we call flex sensors. And a flex sensor is an electrical resistor. By measuring the resistance that the flex sensor is giving, we can determine what position each of your fingers are in. The glove also has an accelerometer and a gyroscope incorporated into it. Now most smartphones have these as well. The gyroscope enables your phone to know which way round you are holding it. So for example, my tablet, as you twist it back and forth, you'll know yourself it goes from a landscape to a portrait view. This allows it to determine which way round your hand is pointing. The accelerometer enables it to measure the movement. And again, these are quite often used in phones and in smartwatches for counting your daily steps. So this again can determine how fast and in what direction your hand is moving. So by taking all these different bits of sensory information, the flex sensor, how your hand's bent, the way your hand's orientated and the way it's moving, we can then determine and process what gesture you are making. Now, if a very simple system could just compare these input signals and then take them and compare them back to what a textbook perfect sign language gesture was saying, and then give you the output that was given. So for example, for the gesture of hello, you'd have nice straight fingers and you'd have a fairly slow movement back and forth like that. It would recognize that as hello. However, we're all different, we're all unique, so we're all going to make that gesture in a slightly different way. So it might be that you're a much more bubbly and enthusiastic person than me, and you make a really wild hello gesture like that. It might be that you just sort of naturally bend a couple of your fingers so that you're more cupped like that rather than nice up and straight. We're saying hello. You and me, once you know the sign language, know that's saying hello. But how does the glove know that we're both trying to say the same thing? Well, we do this via a technique called machine learning. This works by firstly setting the glove to work in a teaching mode. This involves telling the glove what word or phrase you're going to make and then doing it. You then give the glove to somebody else and get them to make the same word or phrase. The glove now knows that both that and that mean hello. If we then repeat this with more people, ideally hundreds or thousands, we can build up a large database that the glove knows means hello, and we can then do the same for all the other words and phrases. Once we're happy that the glove has learned a sufficient number of variations on the action, we then put it into its active mode, which is the usable mode that we're showing you here. So for example, when you say hello, it searches through its memory, compares all the inputs you're making with everything it's got in its memory, finds the best match, and then outputs the hello that you hear on the speakers. Now, as you can see, to make this accurate and useful, it's important to have a large number of people in the system to train it so that's the best chance of matching your gestures correctly. It is also important that the people used to train it come from a wide and diverse background, as there may be cultural differences in the way sort of people move their hands, there may be certain disabilities that limit movement, and the glove needs to understand that all of these mean the same thing. So as you can see, while we are still some way off fully functioning autonomous robots and droids, we can still utilise artificial intelligence and machine learning techniques to make real and positive impacts on people's day-to-day lives.